How do girls know words like ever saw?
Because they're girls.
How do the guys not?
I'm not in it. I do homework during my stage off time, so.
Which is
do I.
second to none.
So what?
So I'm just not focused on the words.
I can, the melody I
You've heard it so many times.
the
So
melody.
is this solution on these problems going to be yes or no?
Huh?
Are the answers going to be yes or no?
Jake, whether I'm just
Yeah, but you gotta prove it with math.
oh.
So yeah, ultimately, the end goal of what we're gonna do today is yes it will or no it won't, but you gotta prove it with logical.
Mr.
Yeah.
I finished.
I told you.
Spaghetti's probably my favorite meal.
Okay. So today we are going to talk about mixing two solutions together. Okay, and when you mix two solutions, it's possible that even though those solutions were completely soluble, when you mix the two together, you could get a precipitate to form, and we will talk about why it could potentially form, and in certain situations when it won't. But before we do that, I want to talk about something that's we have not talked about yet, and that's the common ion effect. So what this says is, let's say I took salt and I dissolved it completely in a solution. So I should have my ions. Correct? Okay, those are my two ions. I can write the KSP expression for this. Okay? I then could take another salt and insert it into that same solution with a common ion. When I say common ion, I'm saying there is an ion in NaCl. It's the same kind of ion in one that I'm going to introduce. So for example, let's say I introduce AgCl. What is the common ion?
Cl.
Yeah, okay? When I add AgCl into here, wouldn't that increase the concentration of chlorine for the other guy?
Yeah.
And the same thing could be said about the chlorine from NaCl would increase the concentration of chlorine for AgCl. That make sense? Okay, so I could write the KSP expression for both. They both have a chlorine ion in it. Okay? When you take two salts with a common ion and put them in the same solution, a lot of times, if you have more ions than are able to be held in solution, the least soluble one will precipitate out first. Okay, so what I mean is, let's say the KSP for this guy is 1 times 10 to the negative 6, and the KSP for this guy is 1 times 10 to the negative 10. Okay? And when I introduce these two in here, I have too much chlorine ions in solution to be able to be completely dissolved. Which one will precipitate out first? NaCl or AgCl? Which one will precipitate out first?
NaCl.
Ag, why?
Resin.
In this, AgCl can only produce a smaller amount of ions in solution because of the smaller KSP. Okay? So if I have too many chlorine ions in solution, the one with the smaller KSP will start precipitating out so that it can get back to its correct saturation point. Okay? That is essentially what the common ion effect is. If you take two salts, put them in the same solution, and you have more ions than are able to be held in that solution, the least soluble salt will precipitate out first. or the one with the lowest KSP? Okay.
All salts taste the same?
Taste the same?
What?
I
No.
don't know. I would assume not, but I'm not just gonna go licking all kinds of different salts.
Let's watch that one video again of the alkali earth metals.
Okay?
Love that video.
So this is going to kind of lead us into what we're going to talk about today. What I want you to know about the common ion is when you introduce two salts into a solution that have a common ion, the least soluble salt will precipitate out first. Okay? Because you can't have more ions in solution than the solution can hold. Okay? Next, what we're going to do the rest of the day is we're going to take two solutions and we're going to mix them. And we are going to predict whether a precipitate will form. Okay? These aren't common ion situations. It's a little bit different, but we still can follow the same idea. And we can also predict how much precipitate will form. So let's do this problem. Just get to wherever you need to be in your notes to follow along here. There will be a pretty lengthy amount of math here, so please use your space wisely. Okay, on yours, it looks like you don't have all the information you need in your notes. You need to make sure that you put this in your notes. And probably, does it say predict whether the precipitate is BA,
We don't have that problem.
You don't have that problem at all?
Yeah, we do. Here. It's underneath the KSP precipitation.
That's
That's not the same.
That's different.
It's, yeah, is it barium nitrate and sodium carbonate?
Yes.
Yep.
Yeah.
It's just, I didn't give you the complete information. You do not have this.
Weird digest edition.
You have this, and you have this, and you have what they are. Okay? So what I want you to write in addition to what you have is this. I want you to write this, and I want you to put somewhere those two things. So what is the question asking us to figure out?
Will BaCO3 just
Okay?
precipitate?
I'm gonna try to take this slow and kind of give you some visuals here. Let's say we have two beakers. Okay? In the first beaker, I have BaNO3. Okay, that's going to go into the beaker, and when it dissolves, it will produce what?
Saturated solution.
Ba2 plus and
Never mind.
Minus.
2NO3 minus. Make sense so far? In the other beaker, I have Na2CO3. And I input that. When it goes into solution and dissolves, what's produced?
Na,
2Na.
2Na plus, and CO3, 2.
Yep, CO3 2 minus. Okay. So I got beaker 1, beaker 2. Do I also know the concentrations of both of those salts? Did they give it to us? Concentration of the first salt? Concentration of the second salt? What's that? Right up in there. Now, both of these salts are completely dissolved. Okay? So I don't have any solids sitting at the bottom. Now I'm not saying that either of these are at the saturation point or not. I'm just saying they're definitely not supersaturated. There's no precipitate sitting at the bottom. Does that make sense? Okay? Then what is happening is I'm taking these two and I'm combining them into one. Okay? So then I should have four ions here. Following so far. Okay? Now we already said this and this aren't going to bond to form a precipitate, because if it didn't up here, why would it down here? And this aren't going to form a precipitate, because if it was soluble up here, why would it not be soluble down here? Why would it be soluble down here? The only way I could make these unsoluble would be to reduce the volume, but I didn't reduce the volume, did I? No. Okay? The question is, will a precipitate of barium and carbonate form? Was barium interacting with carbonate before I mixed the two solutions?
No.
No. So all I want to know is, what is the equilibrium between those two ions? Could those potentially, now that they come in contact, could they potentially react?
Yes.
And precipitate out? Yes. And we want to figure out, will it precipitate out? And here's how we do it. You're going to want to write this somewhere. We're going to compare the theoretical saturation point, or the theoretical KSP, to my experimental situation. When your theoretical KSP is greater than your actual KSP, do you think a precipitate will form, yes or no?
No.
Is it 3?
Yes.
No, right?
Yes.
Yes. That means it's super saturated, right?
The question is, which one of those two is my experimental? Maybe I should
The
replace the word.
actual, or, yeah.
So if the
I'll
actual
switch
has
this.
less concentration, then it's
I'll
not
say
going to
experimental, maybe that will help.
So no. Right? No?
Yeah, it will not precipitate. This is my saturation point, correct?
So that's less.
And if this is less than my saturation point, will a precipitate form?
No.
No. So in this situation, I'm just going to abbreviate. I'm going to put no PPT. That just is abbreviating precipitate. Does that make sense? And I could also then do the opposite. Oops, write KSP now. Oops. Yeah. I want to do that, everybody. Oopsies. Now in this situation, this is my saturation point, the max amount of ions I can have, and if I have more than the max, it would be supersaturated, but what's more likely to happen is it will precipitate out to reach the saturation point. Does that make sense, everybody, so far? So I would say in this case, PPT will form. So make sure you put this in your notes somewhere, because I can guarantee you on your test, you will have to predict if a precipitate will form. Okay? Again, that is the quick memorize without really understanding versus using understanding to be able to not have to memorize. There's a difference, right? Okay.
What'd you?
So there's a difference between understanding and not having to memorize versus memorizing because you don't understand. Now, all of that is kind of pre-work to do the math problem. Okay? It gave me this. What do you think this is?
The theoretical.
It's the saturation point of the particular salt I want to find if it will precipitate. Okay? So if this is the theoretical, I probably need to find the actual or experimental. Yep. Okay? So, this is going to take a little bit of work. In order to do this, notice that these two ions come from different things. Okay? So what I think is the best way to start is to write the equations for both of your solutions to begin with. So we have BaNO3, and we kind of already did this. We said it was Ba2 plus and 2NO3 minus. That's our first salt, and our second salt was this. There's my second. Now we said we want to find the experimental KSP of this, so I probably need to write the KSP expression of this, correct? Okay? So over here I'm going to write the equation of this so that I can write the expression. Following so far? Am I going too fast? What was that? No? Maybe? Okay? Stop me if you're like, I'm doing something and you're not following. That's your job. I don't know what's in your brain right now. Okay, so I'm just going to write this. Okay, what's the charge of Ba?
-2.
Negative.
2 plus.
2 plus. And you can find that by looking at the periodic table, correct? Notice I have a 1-to-1 ratio here, so what has to be the charge of carbonate?
2
Minus.
plus minus.
Where are you today, Gage?
That doesn't really. No, like I said,
What?
Doesn't
Are you
really
okay?
make sense.
no. I'm not gonna say no.
Wait, why are you doing that?
We're gonna be.
When I want to find whether the KSP of this, so I can compare theoretical to actual. They gave me the actual,
Oh,
or
you're
the theoretical. I need to find the experimental. Alright? So I'm going to write the KSP expression. There's my KSP expression for my experimental KSP.
Wait, so we're using theoretical values to solve the experiment?
Yeah. We're solving for the experimental to compare to the theoretical. The only time we're going to use the theoretical is at the end. I haven't touched the theoretical yet.
Aren't 1.0?
There is no theoretical when you're
There's
just-
theoretical?
No. Those are real life experimental numbers.
Okay.
Yep. Now, I just stated that we want this because this is going to be my experimental. Okay. What do I need to find the experimental KSP?
Numbers.
Concentration of
BA.
and CO3. Can I find those two things?
Yes.
Yes.
Just do it individually though.
Okay. Do I know the concentration of this?
Yes.
Okay. So I could find the concentration of both my ions. Now, do I need both of them?
No, you only need one.
No, I only need this one, but I'm going to show you how to find both of them. Okay?
Wait,
Okay?
NO3 minus
The,
Do some S's.
yeah, there's a Q, but I don't need that. I just want to know the
So
concentration.
it's.
I'll show you. Just,
5.0.
okay? Do I know the concentration of this?
No, but you're gonna.
You
You know the whole
yes.
thing, but not
Yes.
just now.
No.
I know the concentration of this because it's this,
I thought you were just talking about it now.
right?
So this is the number of the exponential?
I'm not putting it into the expression. I'm just trying to figure out the concentration.
I thought you were talking about it just now. I thought you were asking, do I know the concentration of just now?
Not currently.
So it's the whole thing.
Okay? The whole thing, I know, it told me. It has a concentration of 5.0 times 10 to the negative 5. This would be our theoretical S from the other day. Right? So, if this is a 1-to-1 ratio, what is the concentration of this?
Same, that's the.
Same exact thing. Now, I don't need this, but I'm going to show you how to find it anyways.
Double.
1 to 2 ratio. So if I know the concentration of this, the concentration of this is 2 times that. Okay? Remember, this is what I want, but I'm showing you how to do both. Okay? Now, that's only one of the 2 things I need, correct?
You need CL.
I want this. Where is that going to come into play?
Just that
Over
one.
there. Okay? But don't I know the concentration of this?
Yeah.
What is it? Okay? So I can find the concentration of my sodium, and I can find the concentration of my carbonate.
Hey, was it just a loogie?
What in the
No.
world?
As long as it's bang.
That was not a great 3. I realize that. Okay? So, how am I going to find the concentration of those 2 ions based on the information they gave
Well,
us?
that one's double, and that one's X.
Okay? So because this is a 1 to 2 ratio, this would be double. So 2 times,
Oh, so you just look at the combination.
right? This breaks up into twice as many particles, and if it has this many moles per liter, it has twice as many moles per liter.
I just got my mind around that.
Okay.
That's not, okay.
1 to 1 ratio here.
Okay.
So if I have this many moles per liter of this, when it breaks apart completely, I will have the same amount because of a 1 to 1 ratio. Which one of those 2 do I need though? Okay, so I want this and this. I don't really need this and this, but I was just going to show you how it works. Make sense? Everyone so far?
Okay, so I have a question. So that 5.0 times 10 to the negative 5th, that is not the KSP.
No, that's the solubility. Molarity.
They're not.
Okay.
That's not the case.
Okay.
Yep.
Because I thought, I was like, why he's not doing that equals when the S is.
Well, technically this would be S, S, 2S, but I already know S, so I can figure out what the other two
I was
things are.
thinking you would plug it in for like KSP, put it on that.
They come from 2 different things, so it's not, you can't just simply do that one.
That's what I was thinking.
Now, once I have this and this, what can I do?
Plug it in.
Plug it in. I'm running out of space here.
There's a whole chunk in the middle.
I don't like to just take a piece that has nothing to do with over here and just plop it right there.
Just go keep it
I feel like the order of thinking gets messed
Arrows,
up.
boxes.
You're okay with that? Arrows?
No, just go
Yeah.
downwards.
Natalie.
Down.
So I'm replacing concentration into my equilibrium expression.
This is when we really start.
Concentration, plugging it in to the equilibrium expression.
Why did I write this? I still like these.
And then what am I doing with those 2 numbers?
Multiply.
To find.
Your KSP.
And then after I find my KSP, what am I going to do?
Compare it to the
I'm going to come. Thank you, Morgan. Good job.
Alright.
Hey, but
Can somebody multiply these 2 numbers for
just
me?
because this one is 1 to 1,
It may
when
not
you plug
be.
it in, you have to make sure that
Yes, be
It
careful.
can't be-
You still write the equilibrium expression based on the ratios here.
yeah.
But you get the concentrations
Five
from there.
Times
So,
5 times 10 to the negative 8.
5 times 10 to the negative 8. So that is my experimental, right? So the question is the experimental KSP greater or less than the theory KSP? Compare this to this. Which one's greater?
The 5
Experimental.
times 10 to
The
negative 9.
experimental one is.
Wait, what?
This is a bigger number.
Negative 8.
Oh, you're right.
So, if my experiment has more in solution than the saturation point will allow,
Wait, what are you just
My solution has more.
the theoretical KSP. I told you to write that in.
I did, I just didn't know what it was.
Everybody see what I'm comparing this to? This is what I experimentally found. This was the theoretical saturation point that they have to give you. Okay? This number is bigger than this number. The more negative you go in an exponent, the smaller the number gets. Yeah, removing the decimals.
Right, you're just adding
left.
zeros in front of the decimal.
Okay? So, will a precipitate form?
Yes.
There's your answer, and there's your proof.
Wow. I followed, but that's a lot.
It is a lot.
How many problems are on this work?
The answer is literally.
Now, I did a lot of background stuff. I talked about this. I talked about what's happening. Like, if you got rid of all that part, it wouldn't have been quite as much stuff.
Sure.
If
Okay.
you just think of what you need to do.
So,
really.
on the next problem, there will be more space here. And I think I can go through this one a little bit more quickly without doing that stuff, and maybe it will sit in here.
Will it ask us like which one will participate?
It should. You're talking about which one you're trying to figure out the experimental for?
Yeah.
Yep.
So would we just put barium?
Sorry, what?
So would we just put barium if it's asking, if it asks which one will? If it did ask.
I'm not sure what you're, when you say,
Well, it never asks like will it precipitate and then if it does which one, whatever do that.
oh, it'll probably specifically ask you, will this one precipitate? You're asking whether either of them will? Because you could technically have two, is that what you're saying?
Oh, I thought I was just asking if like on the test it would ask, like after you do all this, will it ask you, and then where to find that?
Do you guys understand? I'm not sure I
It's like,
understand.
will precipitate form, and if it will, which one, I think is what you're doing.
Yeah, like just like barium or
We only
something.
did, oh, that's one, they're together, one.
Oh,
Okay, those ions combined to form that.
okay.
Yep, and that's what we were trying to figure out. So, in this particular situation, same setup, do I have two solutions? That one and that one. Okay, and what are they asking me to figure out if a precipitate will form? Of what? Of this. Now notice, chlorine came from here and lead came from here.
To make one.
Okay? So that would be the two beakers, right? Mixing into one. Now the Pb and the chlorine can come into contact. Okay? So, write the equations for both of your things. Thankfully we've done NaCl quite a bit. And I can then do the other one. Uncrisscross to find the charge.
2 plus.
Got two of them.
And 2 NO3.
Uncrisscross the charge. Okay? Ultimately, I'm trying to find the experimental KSP of this guy here so that I can compare to the theoretical. So, if I'm trying to find the experimental KSP of this, I probably need the expression for this. Right? So I'm going to write this equation up here. Duh. Now notice, this isn't a 1-to-1 ratio. Which, not a huge difference from last problem. I just write the expression, and I just do well with it.
Yeah, just do it how you usually do it.
Yeah, I mean, no different, I'm just putting that 2 up there. Right?
I was thinking.
So, when I find the concentration of chlorine from here, I'm just going to plug it in here and square it. No big deal. And when I find the lead from here, I'm just going to plug it in and solve. So I need to find the lead concentration and the chlorine concentration, and where am I getting them from? From there. Here and here. And do we know the concentrations of these two things?
Yes, we do.
Yeah.
We do. Right? So, concentration of table salt is that, right? Concentration of this salt is that. Ooh, I made a big mistake.
What?
I'll tell you that after doing this one. But then I'll just stay with me. I made a big mistake, but I'll tell you what. It's not a big deal. Just stop freaking out. Let me explain it.
It's not a big deal.
Thanks. I made a mistake, but it's easily fixed. No, follow. Okay? What? I'm just going to find the concentration of the one I desire this time.
Okay.
Is that cool?
Yes.
So I desire this one. What's its concentration based on this information?
0.01.
Everybody understand that? It's a 1-to-1 ratio. So when this completely dissolves, I will get the same amount of particles of chlorine as I had of this. Okay? I want that. That's good. How about here?
0.02.
1-to-1 ratio. So here's what I forgot to do last problem. Okay? It says I'm mixing equal volumes. When you take 2 beakers and you put them in one, the volume is doubled, right? Isn't that going to change the concentration?
Yeah.
Oh. Yes, but it's an easy fix.
Yeah, just
If you
divide by
double it, the concentration is going to be cut in half. Because you're diluting it. Does that make sense?
Oh.
Wait, so the last one was
So you just would have had to take those numbers. The last problem, the numbers we put in here, we should have divided both of them by 2.
what? Are you kidding me?
Not a huge deal.
So we have
Okay, I just forgot
So
that
we got
one
the
little
answer
thing.
wrong.
Can you guys
Divide the product by
this,
2.
each of the concentrations by 2. So let me explain what I mean. This, the number I'm going to put in here is 0.01 divided by 2.
Are you sure that's right?
Yes.
You know that, okay.
Yes.
What the heck?
And this I'm going to divide by 2. And the reason why is, this is the concentration before I put the other volume into it. Right? If I got beaker, and you put in, these concentrations are before I mix them together. Won't I have twice the volume when I put the other one in there?
Mm-hmm.
So it's moles per liter, and if I have twice the volume, I'm going to have to divide by 2. Okay, all that we did wrong on the previous one, same process. All the process of what we did a second ago is exactly the same. You just got to take the numbers that you plug in here and do what with them? Divide by 2. So then, we will come here, don't worry, we'll get through this. 0.01 divided by 2. 0.02 divided by 2 and squared.
Why is it squared?
Because of writing the equilibrium expression of the coefficient there. But if you were writing a equilibrium expression, just like what we did last week even, you would put a 2 here based on squared, right? Now, I'm just going to, for the sake of time, give you the answer for that KSP. 2.5 times 10 to the negative 7.
No.
Did I do it wrong?
No. This one.
Oh, okay. So this is experimental, correct? What am I doing to finish this problem? Comparing that to theoretical. This one's quite a bit smaller. You got to get that down before you. More negative exponent means it's a smaller number.
That number
this-
means
Why is
there's that
that?
many zeros.
But that was
after that.
my brain. The answer to one is smaller.
I'm pretty sure that's the right answer.
Oh, yeah.
Do you need to do
It's
the
smaller
right?
with more zeros.
You probably need
That's only if
I
it's
know.
negative.
I did. What?
Only if it's negative exponent.
Wait, what?
It's only if it's
But
a
do you
negative.
need to do like the color?
If this is a positive, then that number will be way bigger.
Yeah, I know.
Then
I'm
why'd you
saying-
ask me why?
I'm saying, I can't.
Yeah, we need a worksheet.
Hey, don't leave. I gotta give you your worksheet. Okay, we'll get it.
Yeah.
I'll figure that out. Just hold it. Hold it.
So cold.
I left it in the cupboard.
Oh my land. My hands smell like worms.
What's your problem?
Yeah.
Rubo, yeah, Rubo, yeah, Rubo, yeah, Rubo, yeah, Rubo, yeah, Rubo, yeah, Rubo, yeah.
you put the smiley face on her quiz?
I'm a non-annihilation here.
Oh, yeah.
Me too. Yeah, the only one we walked out.
95.
No, I got a 90 because when I was trying to she should have put the equals to the variable.
Yeah, that's what I did too.
On two, K, E, Q.
I just bought a bike for this, so I lost all my money. Now I have to go like an hour.
Literally, well, that.
I know, that's not a 90
Yeah, you're right. But it was just a small thing that I forgot.
Okay.
Scout.
I'm just saying.
Hey.
You call me a girl?
Yeah.
Now Scout is a girl?
I mean,
No,
I can't. Scout is a girl.
Yeah, that's what I'm Scout.
he got a 36.
Really?
I thought that was gonna be more.
I got a 31 too. Dude, really?
I think I got a 30, sorry.
I don't know.
I don't know.
Why is there mulch?
Because mulch.
That's not mulch, that's hay. That's hay, Bree.
Like mulch.
Next year's room.
I'm trying, I'm reaching my God. I got it.
I think I just ate something because like I was eating
oh, I know why. I'm an idiot.
Oh.
I put lead in for
Honoring.
Thank you.
That's why I can't remember.
Laugh it up.
We didn't do lead.
Yeah.
Oh, so the point of 1 over 2
Yeah.
needs to be squared.
Because it's square.
Yeah.
Oh, okay, that's.
I just take a picture of that someone had erased that picture so I don't get it wrong.
Yeah.
Let me
What do you
erase
say?
Delete it.
Delete it. I'm sorry, I used the wrong word. Like,
You know what
mock.
she
said no word wrong.
Okay, I was just checking. There should be 0.02 divided by 2. And then 0.01 divided by 2 should be squared.
That's fine, guys.
Wow, I made a couple goofs.
Yeah,
I was on my game other than 2 things. Gosh darn.
there you go.
Yeah.
Yeah. I'm gonna pull out the chemistry book and start going to Smoky Road.
It's the shirt.
Gotta go to Smoky Road, get the chemistry book now and reveal.
Sacrifice of Jesus Christ.
No. Where did you find all the pictures? Go to photos at the top.
I am the sun. I'm a burning ball of fire.
Life on earth depends
Just saying the sacrifice that God has done for us.
I am the sun. I am Jupiter. That's on one, that's okay. Stop!
Ever done
I don't believe in this.
Good thing I brought my
Number 4.
I'm just.
What?